So today's session is all about data diagnostics, and we'll focus on what it is, why it's important, the impact on how we do network studies, and Mui Van Zandt and Jing will be walking us through our tutorial today using the fluoroquinolone study as an example. And just a few quick reminders. Session is recorded and will be posted and available for your viewing at a later time. It's going to be posted on the SOS Challenge homepage, and I'll put that link in the chat here again. With that, Mui and Jingli, I'm going to turn it over to you.
Hi, let me know when you guys can all see the screen.
I can say that.
We can see it.
Okay, cool. Welcome to week 2 of the SOS Challenge. Like Jody Ann just said, we are here to talk about data diagnostics, okay? So hopefully everybody will get very excited and be really wanting to participate when we're done with this tutorial. Not that Chan's tutorial was not exciting enough last week either, okay? But every week we want to get you more excited. So what is data diagnostic, right? And how does this really apply to the study that, this whole process in the study that we're looking at? Now, before I go into there, this is what Claire set up. I want to, first of all, say thank you. I know she's not on this phone call, but Claire did a lot of upfront work, and this deck actually comes from her. So I'm just stealing the credit from her, okay? She has this really cool format that I love. It's called Know, Understand, and Do. So for the purpose here, we're gonna give you some information on what to know. What is the data diagnostics, right? What is data diagnostic? And what do you need to understand is how it can be used to create a profile for a given database, as well as how to fill out the diagnostic input, okay? And then what we're going to then do with it is we're going to interpret the data diagnostic output for one of the SOS samples. If we can, maybe we'll get to more than one. In the earlier session, we got to 2. Maybe on this session, we're better and we'll get to all 4. Okay. So the agenda today, there's really 4 main topics we want to go over. First one is an overview of the data diagnostic. The second one is really building the database profile together. And then Jing will show you guys how to do that. Once we finish building the data diagnostic together, the profile together, we're going to show you guys how to actually input the study questions into the data diagnostic tool. And then finally, we're going to go through the results in our Shiny app. Okay. So first thing is the overview of the data diagnostic. So what is it? What is this thing that you guys have not heard about, but hopefully will be extremely excited about? Okay. First of all, it's an R package, of course, right? Odyssey. We do lots of R packages. Basically, it's an R package that's going to allow us to determine which database might have the elements required to answer a research question. Okay. Using a set of aggregate summary statistics. Now I'm going to stress that there's summary statistics. We're not looking at, the patient level record of a patient, and those that actually participated in the study or are going to participate in the study. We want to put out there that your data is not going anywhere. And again, we're going to specifically stress that it's aggregate data, and we're going to keep all this in a central location in the Odyssey Center, just specifically for the use of these 4 studies. Okay. How does it work? Okay, so this process, what it is you guys today probably run your Achilles reports, right? And there's a database profile that already exists. So what this data diagnostic does is actually pulls information, counts really, high-level counts from your data profiles from each different databases here, and puts it into a metadata table. And that gets sent to the Odyssey Coordinating Center. And then within the data diagnostic tool, the user puts in the impacts for the parameters of the cohort that they want to run. And then we run that against these metadata tables. And then the output creates the shiny report that tells us which one of these databases may be the best fit for your particular study question. Okay. So here's a list of the summary stuff that it actually collects. Again, we want to stress that it is summary. So things it collects, for example, it collects a lot of things based on person, right? Total number of patient, by gender, by year of birth, by race, by ethnicity. But again, it counts. There are counts of these things. It collects certain measurement information, counts, condition information, drug exposure. It collects your count of each drug by concept ID and each source drug by concept ID. Devices, observations, a lot of these basically high level aggregate counts is what we end up collecting. Okay. So that at a high level is really what the database diagnostic is. Now, before we go building a database, the profile itself, I want to show you guys, and I'm going to put this into the onto the chat. This is where all the information is about the data diagnostics. Okay, so there's a README file, just like any other GitHub repository, right? There's a README file, talks a bit more about how it works, how you can set up the connection, how to run it, how to upload the results into your local database. But basically, it goes through a lot of this information. Okay. Now, anybody can get to it. And what we would love is for people to actually, when we're done with this, go over and actually look at this, download this, and actually we would love for you guys to run this on your database. Okay, and then send us the results so that we can actually use it for the 4 different studies itself. Okay, so that's my very quick introduction of the database diagnostic tool. So I'm going to send it over to Jing now, who's going to actually show you guys how the R package actually works and how to run it. Okay, I'm going to stop sharing. Jing.
Let me start sharing my screen. All right. So as can you hear me well? All right.
Yes, you can hear.
So as Mui shared earlier, so we can download a package from GitHub, and then we will, as you can see, very familiar, you know, all the standard Odyssey package. When you upload it, you'll see kind of all of the code here. So you will go to extra, and then there is a default code to run, which has more of, you know, all the general information that you can fill in order to get it to run. So here I actually want to share 2 different options for it to run. So all of those are, you know, packages you want to install again, install if you have not done it already. But so those are kind of the preparation work, very similar to other packages. And then you want to create other connections to your database. And this will really differ on kind of what database you're using. And for us with Snowflake, which is also a newer addition to the connection, to the database connector package. So we have to use kind of a newer version of the database connector to get it to run. But if it's, you know, the regular SQL servers or AWS, you probably will be fine with the 5.2 version or even under. But for us, we have to use 6.0, I think. Sorry, I can't remember. But anyway, we'll need to use the newer version for database connector. So that will really depends on you. But if you have any questions, we're more than happy to help, kind of, because this will really differ by database. All right, and then CDM version, also specify yours with 5.3 or 4. And next step would be to execute the package. So as you can see here, this is execute DB profile, which is a bit longer than what the default database diagnostic the final execution function. The reason for that is if we run this will be this will have a lot of questions pop up for us to fill, such as, you know, the name, you know, what's the our participation, the data name, the contact name, you know, all of that. So we're just making all of the so you can either specify using this way, which is the default that will just pop up, like, let's say, I think 10 to 15 different windows for it to type in the information on your data. Or if you have multiple data set and then all of the informations are essentially the same, that you don't need to kind of manually type it again and again for each of your database. So let's say if you have 5, you have if we do it this way, you need to type in the pop-up window like 5 different times. So but that's a default. If you want to change it and just write your information, like probably in the hardware we just hard-coded all of the information that would be in the pop-up here, which will be the same for all of data, and then we can loop through all of the, let's say 5 different databases kind of quickly. You don't need to stop every time to write that, and then just loop through every single one of the database you have here. I will stop here, but that's essentially the 3 different steps of the package. Get all the package installed, connect to your database, which will work for you and your database setting. And then the last one, the execution function, you have the option to kind of either do a pop-up window, or you can just, hard code all of your data information into it, and then hit the run button and then run the whole thing. Any questions?
So
I have one.
go
ahead.
Yeah. So how can I share the results from the DB profile?
You will have output. You'll have 3 different output. So there will be, let me quickly show. So first of all the results from the all of the results from this deep profile that package are all aggregated. So you don't need to technically we don't need to do any additional masking or anything, if you know what I mean. Like, we don't need to do that anymore. But then in the same time, you want to look through your results before you send out. I think everyone will be, for that. So I can share. So there will be 3 different packet Excel files that will be the output.
So that connection source is the source of the data, and the execution DB profile is where the analysis will be done. Is that correct?
Yes, correct. So we need to first kind of, because sometimes, although it feels like, we're just connecting to the data, but there could be some errors that you may or may not run into, but it's essentially, we need to have the right version of database connector package that will meet your your data setting, whether it's on the cloud or physical server or whichever server version. But just if anyone else is on Snowflake is newer, added to the database connector. So just make sure you are on the latest or a newer version of database connector to connect to a Snowflake database. But the regular one should be okay, because they are all included in the previous version of database connector as well.
Nicole, your hand's up.
Mm-hmm.
Yeah, thanks, Jing, for that overview. Some data custodians require specific rules for even aggregated data to be distributed.
Mm-hmm.
For example, minimum cell counts or other things. Are they things that are inbuilt into the data diagnostics, or is that something that you can modify, or do you have to do that in the data viewing step? So
yeah, that is very good question. So I know, there will be probably a minimal cell count. If a subgroup is less than, let's say, 10 people, then we don't report it anymore. So in the result setting, there will be, what's the patient count and all that. As far as I'm aware, in the main package, in the main code to run here, there is no specification for if there is a masking rule of, if it less than 10 patients, we just skip it or just put a 10 there. I don't know. That's a very good question. I think it's not here, but it may be in the main function behind this.
There's a function in this. If you watch the one in the afternoon, Claire actually talks about it. where we actually thought about that. It's not only about the number, Nicole, because that can be a threshold, but also particularly if you have specific concepts you don't want to report on as well, right? Because some hospitals do find those to be sensitive, right? Not just hospitals, even us. There are certain diagnosis codes that we do not want to report on because of the potential risk of re-identification of the patient. In our case, in your case, it may be the risk of a re-identification of the site itself, right? So there are parameters that you can set. I don't see it here, but if you watch the one in the afternoon that Claire did, she does show where that is.
Okay, great, thank you.
The other question I have, Jing, like how long did it take you guys to run this on one of your data assets?
Yeah, that's a very good question. So it really depends on how big is the data. So I'll give everyone just a quick, I think for a database that's around like, let's say 2 million, 1 million patients, 1.5 million patients, it took around 10 minutes to run. But then it's, and I guess it also depends on the server. It depends on the server settings, and also depends on your database size. So for around 2 million patients was 10 minutes, and then for those big, almost in a billion patients, a database is run for like, I don't know, more than 5 hours. So it really, really depends on how rich the data is and probably how busy the server is. But essentially, I think if we're talking about one hospital data, which is like probably around a couple millions or something like that, it shouldn't take no more than, let's say, 20 minutes. So once it starts to run, it should be pretty fast.
So, Jing, do you mean that when you are using the Achilles results, it took 10 minutes, or if you rerun the Achilles, then but it took 10 minutes?
Oh no, it's for all of the time I was mentioning are both using the Achilles results, are based upon the Achilles results. We didn't rerun any of the Achilles, which will take much longer for sure.
Okay.
Mm-hmm.
Any other questions?
Yeah, I'm just gonna ask a stupid question, is because I'm fasting and I haven't had food the whole day. So it seems like this is simple. So all I would have to do, this is me not knowing anything, is download this R package, run it on my local server, point it to a database that I want to run diagnostics on, set these thresholds that you set up on full name, etc., and just run it. And when I run it, if it runs error-free, it should give me 3 files as outputs. Is that correct?
It actually gives you a zip file as one of them. And what is inside that zip file, if you guys can see on my desktop right now, is what's inside those 3 files. Okay, so apologies, they're kind of small. I don't know how to make my file explorer bigger, but you'll see that this is actually on one of our databases that was executed. So it'll give you the database results file. It'll give you the CDM CDM source information, and also the metadata. So if I click on each one of these, right, if I really gonna click on every one of these, I should have clicked on them a little bit earlier. Let's see if they'll pull up. Right, but it like I said earlier, what it does, it in the database results file, it gives you counts. It's actually lists out all the different counts of everything I showed you earlier, right? This hospital one down here, this metadata, it's that metadata that Jing put in. What type of data is this? X, Y, and Z. So that's what that does. This guy doesn't want to behave. This is what happens when you try to do a demo live. Okay, there we go. Yes, please. Okay, it's too large. So you can see here, there they go. They all open, right? So this is what she showed you earlier that said that was the cleaner version. This is the metadata that it comes with it. who's the site, what's the site name, who ran it, what's the name, who to contact, right? The source, it tells you basically what's my database source name, what my vocabulary version is, what my CDM version is, and all that fun stuff. So those are two really more, I would say, considered attribute files. This is the file that actually has all the meat in it, right? And Nicole, you said earlier, right? If something, my count, I don't want certain counts, certain thresholds, or I don't want certain concepts, that it won't show up in this file. That's what happens. And in this file, you'll see all the different analysis. Ultimately, you see a bunch of concept IDs in here as well, and then the counts. So it's very high level. Again, it's just giving me counts. So that's all it does, if that makes sense to everyone. Any questions on that? Okay. If not, what I'm going to move on to is now. Yes.
Adam and Danielle has their hands up.
Sorry. Atif, I think we already answered. Danielle?
Yes, sorry about that.
Danielle, are you there? Well, if you find your question, or if you unmute, let me know, okay? So what I'm going to move on to is actually, so now once you've gotten these results, right, Chan, like you said, these are the results file. What then you would do is we would ask you to send it to our coordinating center, right? In this case right now, I believe Claire is collecting all these. So if you send them to us, right, Claire, then we will collect all of this, and then we will put it into an RShiny app, which I will show you in a second. But before we go to that RShiny app, the next thing we want to be able to do, because now we've collected all of these different database profiles, we actually want to define our input, our cohorts, right, or outcomes that we want to be able to look at. So you can see here what's inside this data diagnostic user input application. There are a few things. One, you can define the age range, you can define the gender, the race, the ethnicity, the start and end date, the follow-up period, right, the continuous observation. You can also put in a list of target cohorts, a list of comparator cohorts, a list of, I'm sorry, not cohort, concepts, a list of indications, and a list of outcomes, okay? Now, the only thing of here that's required is actually the target, as well as if you want to say, hey, which one of these domains are either required or potentially optional, okay, desired. So if we look at the, I am going to butcher this name, okay, fluoroquinolone, okay, study, we're actually going to end up building out 6 of these, right? Because we're going to look at fluoroquinolone compared to 3 other different ingredients for UTI against aneurysm, but then we're also going to look at it for pneumonia, for the risk of a aortic aneurysm as well. So if we look at that, there are 3 different drug combinations, and then 2 different indication combinations. So the total is actually 6. If we look at it, this is the first one. We're comparing fluoroquinolone against this other drug for the UTI and the outcome of aortic aneurysm, right? Then the same thing, fluoroquinolone, but against another drug and UTI. And then again, the same thing, but this time against penicillin, right? Then we're going to switch it over back to the same ingredient, but now for pneumonia, right? Again, then the different drug, again, different drugs. So there's a total of 6 that we're looking at that we want to compare to, okay? And if we look at all the different SOS questions that we have, you can see here, like the VEGF, there are potentially different rules and different things we're looking at. Like the VEGF one this morning that we looked at, there was no date range, right, that we're looking at. For the fluoroquinolone one, there is a date range you guys are looking at from 2010 to 2019. Versus this last one here, it's actually anything less than April 2019. For yours, it's looking for inpatient, desired, you prefer inpatient, versus some of these other ones don't require inpatient, right? And this one, we're particularly looking at two different indications here. So you can see all these are the different parameters that actually Claire has spent the time and did the input, and with a few sample data assets, we've actually created the Our Shiny app for this. Okay, so I have to show her little image here. Let's go run a data diagnostic. Okay, so I'm going to get rid of that and bring over what the data diagnostic tool looks like. I have too many monitors. Give me a second. I got to find my right monitor. Okay, so this is the data diagnostic ultimate Our Shiny app. Okay, so data diagnostic comprises of three things, right? One is the data profile, two is the input, three is the actual results afterward that gets populated into an Our Shiny app. Okay, this is a version of the Our Shiny app that we've created. When you come in, it looks like a standard Our Shiny app. It has the About the Odyssey viewer, has a bunch of different references you can go to and look at and potentially use. Okay, this may or may not be very useful to you, because what we're going to look at is really the data diagnostic tab, which is the more interesting tab, right? So this tab, what you can do is actually go and add in the different analysis that we were looking at. And in the APACS case, we're looking for all the fluoroquinolone ones, right? So there's 6, like I said, so we can bring in all 6. We got 1, 2. Luckily, these things are numbered A, B, C, 8, 1, 2, 3, 4, 5, 6. So it's a lot easier to find. So you can see here very quickly, I brought in all 6 of the cohorts that you guys are, we are interested in this particular study. Okay, so here comes the magic and the fun. Okay, if I scroll down, you can see these are all the different data assets that we've actually run the database profile on and has said. And you can see here, all of these so far have passed all of the checks for every single cohort that we just added. Okay, so just by looking at this, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different databases that can be potentially a good fit for this particular study. Okay, now we do have a couple down here that failed. I shouldn't say fail, had potentially an issue. Okay, and that issue may not mean that it failed, because we can actually change the parameters if we want to, right? So let's look at that, right? Let's look at those 2 that are down there that didn't seem to turn red or turn green on us. It turned red, right? So when we go to the drill down, I can pick which one I want. So let's pick this first one. And as you can see, again, this thing is too huge. It's making my screen a little wacky. Okay, less huge. You can see these are all the different parameters it looks like and again, across all of these, they pass. But let's look at the 2 that didn't pass all of the parameters. We can look at it this way, right? And what you can see here, and these are all pre-set up by Claire. Okay, again, you can do this yourself when you put this into the diagnostic tool itself, but you can see we said, okay, we wanted it within this date range, and that's what we picked earlier, right? 2010 to 2019. Well, that passed because the data had it. We wanted people over 35. We wanted the all ethnicities. We wanted all genders. All that seems to pass. What for this particular database, which is Premier, which is a hospital database, it did not pass the longitudinality of 365. So, which means that this database potentially has less than a continuous observation of 365, right? So one thing you can do if you really want to use this, or you might want to investigate, is looking at maybe 365 is too long. Maybe you want to change to the 180. Maybe half a year might be more reasonable based on all the different data that you have, right? So you can actually go change this to 180 and then rerun this again, right? Again, what I want to stress here is just because it's quote unquote failed, doesn't always mean that this database is not sufficient enough for you to utilize. It could be your parameters as well themselves, okay? So you look at the rest, it has the procedures that we're looking for. It has the race we're looking for. It has the comparator concepts. It seems to have the required domains. It has enough drugs and conditions. It has the urinary tract infection. It has the outcome that we're looking for, and it actually also has the fluoroquinolone we're looking for. And more importantly, it actually has the min and max amount of people that we need. Okay. So if you look at all that, that's why that one failed, right? And now if we look at this other one, there's two reasons why this one failed. The first one had to do with the date. So it doesn't see this one. Now, I don't believe the data owner for this one is here, but it doesn't seem to have data that fits this criteria right here. Right. And the other thing that it failed on, if we scoot it over, is it doesn't have enough sample size. The threshold for sample size is 1,000. Okay. So anybody got any questions so far? Am I that good at explaining everything?
Let me explain why Premier data has failed for the
awesome
365 days criteria. So when we conduct the observational study using the secondary data such as EHR or claims, we cannot guarantee that whether the patients have the outcome before the index date. So in this case, the patient might have the aortic aneurysm or dissection before the initiation of the antibiotics, but we cannot guarantee because we do not observe we do not observe the patients for his or her full history. So that's why we usually record the minimum observation period before the initiation of certain drug or the index date. So usually we record the 365 days before. So the patients have to be observed 1 year before the initiation of the drugs or the events or the index date of the study. And in the Premier, because it is an EHR data and only about 1% of patients have the full, enough observation period before certain events. That's why it failed. So we can change the minimum required observation period, such as Mui said, we can change it to 180 days or 30 days to have more patients, but usually it is not recommended.
Got it. Great explanation. Yes, Nicole. You're on mute, dear.
Sorry about that. So just to clarify, Chan, are you saying that the Premier database is a database EHR in hospital? So we only observe patients while they're in hospital, and we don't have community observation, so community prescribing or that kind of thing. So we basically only have the hospital events, and it probably won't work for our fluoroquinolone study because we do need that community dispensing, and we need the observation 365 observation to develop our confounders and that kind of thing. So when we've just got in hospital EHR, some databases won't work depending on the question.
Yep. And that's a great point, Nicole, right? So like all of these, if you can see, did pass the criteria that's been specified. But based on what you just said, you want more of all, the patient history as well as all the observations, right? Some of these, even though they pass, they may not be most suitable for you, right? Because, for example, I come down to like these IQVIA ones, right? They are general hospital, they're not general hospital. They're mainly, most of them are general practice, right? And most of them may not have inpatient setting data in it. So even though it passed, they still may not be suitable for you, right? So again, this isn't bulletproof is what I guess I want to say. It is, but what it does allow us to do is take an initial glimpse at all the different data assets that are part of the study and what may be potentially helpful and what may be potentially, not suitable for the particular study. You still have to go take further steps and take further analysis on these guys, right?
And not all HR have the similar problems, I believe. And I don't know much about the Premiere, but I think that time span of Premiere is really short. So it may
Yes.
spend 1 or 2 years. That's why we do not have enough patients who have the enough observation period for the.
Yeah, Premiere is a pure hospital data asset. It is a collection of hospital records. So yeah, okay. Now, of course, if based on what you guys said, the ones up here would probably be the better ones because these are more claims based, right? So they have a much better depth of that patient, right? So, Atif, you have your hands up.
Two quick questions. As we run multiple databases here, when it runs a diagnostic package, is the system saying that the ones on the top are most preferred, or the order doesn't matter?
It's not it's saying it's most preferred. It actually, it's just in whatever order. It's actually in order of total fail, right? So you can see here, these all have 0 failures versus this
Got
has
it.
1 and this has 2. So it's not that smart yet. This is V1. We are going to try to enhance this a bit more, but V1, it's pretty impressive already. Hopefully that answered your first question. What was your second question?
And this might have been already answered, but for Premiere, where it failed on the longitudinality, are we saying that every single patient doesn't have 365 days of data, or is it saying that majority of the patients don't have 365 days of data?
I can't answer that since I didn't write the analysis for that.
Yeah.
Patrick, are you still here by chance? I think he was, but he might have dropped. I can take that back to Claire. I could take that back to Claire and ask that. I know this morning they talked about a different how the estimates, like you can see here these counts, right? These min and max size counts, how these were gathered. I know how these are gathered, or some of these are gathered, but like this min and max count, how they define the min and the max, it had to do with statistic probability. Now I'm going into a section that I know nothing about, okay? So I'm going to put that as my caveat. What they explained was basically it looked at every single one of the other parameters independently, and then from there took the patient count and combined it, and basically where I think the combination of all of them is the lowest, or where patients met all of them ended up being the minimum count, and then met at least one of them ended up being the maximum count or something like that. But they said it's an estimate, okay? So if you really want to know how that's calculated, listen to Claire's in the morning, okay? See how I'm going back to somebody else's because I'm not the pro in that. The other question that actually got asked was why 1,000? Okay, why?
I was going to ask that one.
That was the other question that got asked, is why is my minimum at 1,000? Because you can see like this one failed for 2 reasons. One was the date, but the other reason is the min and max count, right? The max count, it's 30 people, right? So the minimum, if I click on it, the threshold, you'll see it says 1,000. So the reason why is there's been research that's done to say that to make it statistically plausible to calculate propensity scores and risk, 1,000, you need a certain number of patients, okay? And 1,000 is adequate enough to do an estimation or a risk, okay? Anything lower than that is not as accurate, so that's why the 1,000, okay? Now, that's my layman's term on what they said this afternoon. Again, if you want the expert way of explaining it, you can listen to the recording from this afternoon. Okay, so any questions on the tool and what it can do? I guess my question to Jack, Nicole, and Chan, are you guys now excited that you already can potentially do this on all these different databases, right? At a glance, 11 of these actually met the criteria for, at least had a lot of the parameters that and criteria that you guys can utilize, right? So there are two things we ask. Okay, before I go show you more, there are two things that we ask for those who owns data and really would love, we would really, really, really love you. I'll give you 10 of those little hearts that Chan and Nicole just showed. Okay. If you would run these packages and send us your database profile. Again, it is secure. We are not taking it anywhere. It's only going to be used for the SOS challenge. Okay. And if you could do that and send it to Claire, then we can actually continue to see which databases are really the most fit for purpose for all 4 different studies. Now, what we are going to do is what you see here, this particular Shiny app here will be available for folks to look at. Now, just the Shiny app, not the results that I just showed you, right? These results over here, they will not be shown because these actually detail my entire database. This is actually a profile on my entire database, right? So this will actually not be shared. What we will share is the aggregate of the aggregate of the aggregate. Okay, so these results will be shared with the teams and the public in Odyssey. So we would love to be able to get more so that we can actually run a very, very comprehensive study analysis, right? So now that's your study, Jack. Yes, Nicole. Oh, you on over here, it shows your hands up, but I think it's Jody Ann whose hand is up.
Mui, so for those who are concerned about the time that it takes, can you just talk a little bit more about how long it takes to run?
It doesn't take long. Claire did hers, like she did the SimPuff one. It took her like 10 minutes. Like Jing's earlier said on about 1 million or so patients, it takes about 10 minutes. Right now, again, the caveat there is we did run it on Snowflake. So for us, it's probably a little faster because it's Snowflake and our servers are pretty beefy. We're actually going to run these on all of our data assets this week. But I don't anticipate because it is a summary of your Achilles. So it is looking at your summary data tables. It's not even looking at my patient level data tables. I would be very surprised if it takes more than 30 minutes on any database, regardless of your capacity or your speed.
Mui, I will take you up on that. This is
Good,
Scott from the VA.
Yeah, it's running against your results, right? So it's looking at your results and pulling from your results table. So which I hope are extremely indexed. But yes.
Sorry, you're saying it'll just take 30 minutes for the people who already have Achilles run. If
Correct.
You don't have Achilles run, then
That's
the 30 minutes is off.
Yes, correct.
Okay.
This thing only looks at the results from Achilles. Okay, so if you don't have your results in Achilles, it'll all return 0, and it'll take 5 seconds to run that. Okay, so any other questions? If not, what we're going to look at are some of the other studies, right? So this morning they looked at the 2 other ones. One of them didn't get previewed, so I'm going to preview that 4th one first, and it's the one that has multiple psoriasis on it. No, it's not multiple psoriasis. It was the ischemic stroke. Okay, so this one was the one that we did not look at this morning. Here, I believe there are 3 as well. So you can see here for this particular study, a lot less databases met the initial criteria. You can see a lot of them failed, right? So just initially, we can see that it seems like it's these guys, which are all of the claims databases. Even this claims database, Japan claims database, didn't succeed either. So this is the Medicare version of TrueVen. So that one failed, but it seems like the more general claims database in the US passed. But again, we can go look at why, right? So if we look at this, that one that we just looked at, the first one, it's this one. We can see why a lot of these seems to have failed because there's not enough patients. I believe one of these are about rare disease. This might be the one that's about rare disease.
I think it's probably there's not a lot of people on these medications, Mui. They're
Okay.
quite recent, and yeah, that would be that's my guess.
Okay, because you can see here a lot of these fail because of not enough patients, right? You go across, it's not that they don't have the drug. Some of them don't seem to have the drug, but these guys, they have the drug, but not enough patient count. So for this particular study, of course, by having more databases, then maybe we can run this, right? So again, if you guys can send us this, that would be great. Okay. So if we look at another one of the study, the one like this morning, the US one, which is, what is it called? The VEGF one? It's this one. And there's a third one down here. So you can see this one, 1, 2, 3, 4, 5, 6, 7, 8 passed. But all the other ones seems to have some kind of failure as well, right? But again, that's 8 databases that we can potentially start off with, right, to run this particular study on. And if we look at some of these as well, if it refreshes, no, it didn't refresh. Let me go back to the one at top. We can see here, again, this one failed because of patient count. Premier failed probably because of the longitudinality again, right? So that seems to be a very common thread on the Premier one is the longitudinality. And then this other one seems to have failed on the concept IDs, where the concept IDs don't exist. And because they don't exist, of course, you're not going to have enough patients. This one, it seems to have patients, but just not enough. Okay. But this is what basically the diagnostic tool allows you to do, right? If we look at the PML one, you can see immediately 1, 2, 3, 4, 5, 6, 7 of them is somewhat fit for use, while these other ones, the counts are quite low. So thus, these guys may not be suitable for the study. Everybody, any questions? Everybody excited? Everybody likes this tool? Does anybody not like this tool? Those that do not stay off camera, okay? All righty. There is one last thing I do want to mention. Like I said, this tool is available in the GitHub repository. I did put the GitHub repository out there. And if you are excited, again, please run this. And if you run into problems, don't worry, okay? We make it sound very easy to do this stuff. I know it is quite easy, but we just make it sound probably more easier than it should be, okay? There is office hours starting next Thursday, right? I think it's next Thursday at 10 a.m. Eastern Standard Time. I know that's like that's 10 p.m. for you guys, or some of you, and I think it's midnight for you, Jack, and Nicole. But there is office hours.
Just one correction, is actually this Thursday. So
that's this
April,
Thursday. Sorry,
April 6th.
Yes, it's this Thursday, even closer. Okay. If you have any questions, Scott, or you want to challenge us, Scott, come to the office hours, and Claire will be there to help answer any questions you have or help you troubleshoot how to install this diagnostic, this data diagnostic package. Okay, and if there's a lot of interest in the APAC region as well, let us know and we'll try to set one up in the APAC side. But if not, it is at 10 a.m. Eastern Standard Time, 10 p.m. China time, 11 o'clock Korean time, and I think it's like past midnight Australian time. Something like that. Okay. So that's all I have. Anyone? Anything? If not, thank you very much, folks.